All right, welcome back. Today we're diving into something huge in the world of AI, especially where it matters most, in medicine. We're talking about an AI that isn't just smart, but it's smart enough to know its own limits. And trust me, that one little feature, it changes everything.
So, let me ask you this. What if an AI was dangerously overconfident? I mean, picture it. You're in a hospital, and an AI makes a wrong call on your diagnosis. That's scary, right? But what if it's not just wrong? What if it's wrong, but it's screaming with 100% confidence that it's right? That's not just an error. That's a disaster waiting to happen.
And that right there is the classic black box problem we hear so much about. The AI spits out an answer, but it gives you zero clue about how sure it is. Is it a confident conclusion, or is it just a wild guess? For a doctor, that's a total deal breaker. How can you trust a tool like that when a person's health is at stake? You just can't. So where does this overconfidence usually come from? Well, it often happens when an AI encounters something it's never seen before. We call this out-of-distribution data, or OOD for short. Think of it as the AI's total blind spot. It could be a super rare disease or just a really poor quality scan. Now, a good system would say, hey, I don't recognize this. But a lot of AIs, they just guess. They try to fit this weird new thing into a box it doesn't belong in, and worse, they often do it with this false, super high confidence.
Okay, so if overconfidence is the villain of this story, what's the solution? Well, it's pretty simple, actually. You build an AI that has a little humility. And that brings us to the hero of our story today, a brand new model that's specifically designed for safety because it knows how and when to say, you know what, I'm not sure.
And this quote really nails it. The point isn't to build some kind of all-knowing AI god. The goal is to build a reliable assistant for doctors. The moment an AI can admit it doesn't know something, it stops being a mysterious, untrustworthy black box. It becomes something else entirely, a genuine, safety-conscious partner in the clinic.
So let's get into the nitty-gritty. How does this system, which, by the way, is called FMUE, actually pull this off? Let's pop the hood and see what makes it tick.
It's built on a really elegant three-part architecture. Think of it like a recipe. Step 1, you start with a massive foundation of knowledge. Step 2, you fine-tune that knowledge super efficiently. And step 3, the magic ingredient. You add a confidence meter. Let's break down each of those steps.
Okay, so step 1 is the foundation. And this thing is built on an absolute beast of a model called RET-Found. It's a vision transformer that was pre-trained on, get this, 1.6 million retinal images. That is an insane amount of data. It basically gives the AI a deeper understanding of the human eye than almost any single human could ever get. It's like having a whole library of expert knowledge baked right in from the start.
Now, with a massive model like that, you might think teaching it a new trick would be incredibly expensive and slow. But this is where the second step, the efficient tuning, comes in. Instead of retraining the whole thing, which is the full fine-tuning you see here, it uses a really clever method called LoRa. I love this analogy. It's like instead of rewriting an entire textbook, you're just adding a few really smart, targeted sticky notes. It's way faster and a fraction of the cost.
And now for step 3. This is really the secret sauce, the part that makes it all work. It's a component called the Evidential Deep Learning Head, or EDL. This is what gives the AI its gut feeling, its sense of confidence. So instead of just spitting out one final diagnosis, it actually collects evidence for all the possibilities. It's forced to show its work, and it calculates a score based on how much proof it has for each potential condition.
So how does that actually measure confidence? It's brilliant in its simplicity. If the model is really confident, you'll see a ton of evidence pile up for just one disease. The total evidence score is high, so the uncertainty score is low. But if the AI is uncertain, that evidence is either really low or it's spread out across a bunch of different possibilities. That means the total evidence score is low and the uncertainty score shoots way up. That high score is a big flashing red light for the doctor that says, hey, you need to take a closer look at this one yourself.
Okay, so the theory sounds great. It's an elegant system. But the real question is, does it actually work in practice? Let's look at the results when they put this thing to the test.
And the results are, well, they're pretty incredible. Look at this number, 19x. What that means is that when the AI raised its hand and said, I'm not sure, that case was 19 times more likely to be an actual misclassification. That's not just a small improvement. That's an extremely reliable smoke detector for catching its own potential mistakes before they cause any harm.
And you can see the practical impact of that right here. If you just let the AI run on its own, its accuracy is already very high, about 95.7%. But here's the magic. If you take the small percentage of cases it's uncertain about 5% of them, and hand those off to a human expert, look what happens. The accuracy for all the remaining cases that the AI handles automatically jumps up to 97.4%. This creates a much safer, smarter workflow where the AI and the doctor work together.
So the final test. How does it compare to actual human doctors? Well, check this out. The AI's overall performance was right there on par with expert ophthalmologists, the best of the best, and it was way better than junior clinicians. This is so important. It proves this isn't just some cool academic project. It's a tool that performs at a true expert level.
So what's the big picture here? What should we all take away from this? Because this is about so much more than just looking at eye scans. This is really a blueprint for building a whole new generation of trustworthy AI.
What we're looking at is a repeatable recipe for success. You take a powerful foundation model, you adapt it efficiently with something like LoRa, and then you add that crucial uncertainty meter. That three-part formula is the key. It's a blueprint for building AI systems that can be safely integrated into any field where the stakes are high, whether that's medicine, finance, or even aerospace engineering.
And that leaves us with a really fascinating question to ponder. If an AI knows its own limits, what does that mean for the role of human experts? It suggests a future that isn't about replacement, but about collaboration. The AI could handle the thousands of clear, straightforward cases with incredible speed and accuracy. And that would free up our brilliant human doctors to focus all their time, energy, and intuition on the truly difficult, ambiguous cases, the ones where human expertise matters the most. What a powerful partnership that could be.